Hi everyone. In the previous lecture, we have started exercise 5.2. We have started exercise 5.2, in which we have seen the examples, or we have solved the examples on the basis of section formulae. Now in today's lecture, we are going to see the examples, problems on centroid formulae. See question number 6, exercise 5.2. Question number 6. If two of the vertices of the triangle, if two of the vertices of the triangle are capital A 3, 1, 4 and capital B -4, 5, -3 and centroid of a triangle is, and centroid of a triangle is G, capital G, having coordinates -1, 2, 1. Then find the coordinates of the third vertex. Then find the coordinates of the third vertex C of a triangle. Okay, see here. The two vertices of a triangle ABC are given, that is A and B are given. Also, the centroid G of the triangle is given. We have to find out the coordinates of third vertex, that is coordinates of point C. So, let A, B, C are vertices of triangle ABC. So, capital A is here 3, 1, 4. Point B is -4, 5, -3. Let small a bar, b bar, c bar are position vectors of points or of vertices A, B, C respectively. So small a bar is the position vector of the point A, small b bar is the position vector of the point B, and small c bar is the position vector of the point C. So here a bar is equal to 3i cap plus j cap plus 4k cap. B bar is equal to -4i cap plus 5j cap plus -3k cap. Let the point capital G with position vector G bar is the centroid of triangle ABC. So point G is given here, centroid is given, that is -1, 2, 1. So its position vector is G bar. So therefore G bar is equal to -1 into I cap plus 2 into j cap plus k cap. So by centroid formula, By centroid formula, G bar is equal to A bar plus B bar plus C bar divided by 3. Now again it is equal to, if we shift this 3 to here, so 3 into G bar is equal to A bar plus B bar plus C bar. So again this is 3 into G bar, shift this A bar to left hand side, minus A bar minus B bar is equal to C bar. Now G bar is known to us, A bar is known to us, and B bar is also known to us. Now put the values of G bar, A bar and B bar on left hand side. So we get 3 into G bar here, minus I cap plus 2J cap plus K cap minus A bar. What is A bar? 3I cap plus J cap plus 4K cap minus B bar. What is B bar? Minus 4I cap plus 5J cap minus 3K cap is equal to C bar. So multiply to this bracket by 3, 3 into minus 1, that is minus 3I cap plus 3 into 2, 6J cap plus 3K cap. Now multiply to the second vector by minus sign, so it becomes minus 3I cap minus J cap minus 4K cap. Also here multiply to this bracket by minus sign, minus minus become plus 4I cap minus plus minus 5J cap minus minus plus 3K cap is equal to C bar. Now on left hand side there are I cap, J cap and K cap. So take the terms with I cap together, then terms with J cap together, and then terms with K cap together. So see here, minus 3I cap, minus 3I cap, minus 6I cap, minus 6I cap plus 4I cap, minus 6 plus 4 minus 2I cap. Now J cap, 6J cap minus J cap minus 6 minus 1 become 5J cap and minus 5 minus 5 0 plus 0 into J cap. Now the remaining terms are with K cap. So 3K cap minus 4K cap minus K cap minus K cap plus 3K cap minus K cap plus 3K cap means minus 1 plus 3 plus 2 K cap is equal to C bar. So therefore C bar is equal to minus 2 I cap plus 0 J cap plus 2 K cap. So now small c bar is the position vector of the point capital C. So therefore the coordinates of capital C are, see, we know that if x into I cap plus y into j cap plus z into k cap is the position vector of the point P with coordinates x, y, z, then the coordinates of that point P are x, y, z. So here position vector is known. From the position vector we can write the coordinates of that point, and if it is minus 2 I cap plus 0 j cap plus 2 k cap, so coordinates are minus 2, 0 and 2. So the third vertex of the triangle is minus 2, 0, 2. So we see next problem. Find the centroid of tetrahedron. Find the centroid of tetrahedron. Tetrahedron K having coordinates 5, minus 7, 0, 5, minus 7, 0, L 1 5 3 1 comma 5 comma 3, M 4 minus 6 4 comma minus 6 comma 3, and N 6 comma minus 4 comma 2. So here we have to find out the centroid of this tetrahedron KLMEN. Let small k bar, small l bar, small m bar, small n bar be the position vectors of vertices K, L, M, N of tetrahedron KLMN respectively of tetrahedron. So see here, the vertices of tetrahedron are given, that is KLMN. So from with the coordinates we can write their position vectors, that is k bar is equal to 5i cap minus 7j cap plus 0k cap, small l bar I cap plus 5j cap plus 3k cap, m bar 4i cap minus 6j cap plus 3k cap, and small n bar, this is 6i cap minus 4j cap plus 2k cap. Let here we consider capital G with position vector z bar is centroid of tetrahedron KLMN, of tetrahedron KLMN. So by centroid formula, we know that if small z bar is the position vector of the centroid of the tetrahedron ABCD, then small z bar is equal to a bar plus b bar plus c bar plus d bar divided by 4. Now here the points are K, L, M, N. So by centroid formula, z bar is equal to small k bar plus small l bar plus small m bar plus small n bar divided by 4. So now in this formula put the values of vector k, vector L, vector M and vector En and take the calculations. So we get centroid. See, z bar is equal to k bar. What is k bar? 5 into I cap minus 7j cap plus 0k cap plus I cap L bar, small l bar, I cap plus 5j cap plus 3k cap, then plus m bar is 4I cap minus 6j cap plus 3k cap plus n bar, small n bar, that is 6I cap minus 4j cap plus 2k cap divided by 4. So again it is equal to. Now on numerator there are 4 vectors in the form of I cap, j cap, k cap. So take the addition of these 4 vectors. So we get 5I cap plus I cap, 6I cap, 6I cap plus 4I cap, that is 10I cap, 10I cap plus 6I cap, 16I cap, 16I cap. Now take the terms together regarding j cap. See, minus 7j cap plus 5j cap, minus 7 plus 5 minus 2, minus 2 j cap minus 6j cap minus 8j cap minus 8j cap minus 4j cap, that is minus 12j cap. Now k cap, 0k cap plus 3k cap, 3k cap, 3k cap plus 3k cap, 6k cap, 6k cap plus 2k cap, 8k cap plus 8k cap divided by 4 as it is. Again it is equal to 16 divided by 4 into I cap minus 12 divided by 4 into j cap plus 8 divided by 4 into k cap. So again 4 4s are 16, so 4 I cap, 4 3s are 12 minus 3 j cap, and 4 2s are 8, so 2 k cap. So this is your z bar. So z bar is equal to 4 I cap minus 3 j cap plus 2 k cap. Now this is the position vector of the centroid of the tetrahedron K, L, M, N. Now the coordinates of centroid are the coordinates of centroid are 4, minus 3, 2. So this is the centroid of the tetrahedron K, L, M, N. Okay, next question. If centroid of tetrahedron OABC, if centroid of tetrahedron OABC is 1, 2, minus 1, where the capital A has coordinates small a, 2, 3, capital B has coordinates 1, B, 3, and the point capital C has coordinates 2, 1, C, small c, respectively. Find the distance of point P having coordinates A, B, C from the origin. Now see here, the tetrahedron is given. The vertices of tetrahedron are given to us. Centroid of tetrahedron is given. So, with the help of centroid formula, first we have to find out the values of A, B, C. Once we get the values of A, B, C, we have the point P having coordinates A, B, C, and then find out the distance of this point P from origin. So, see here. Let small a bar, B bar, C bar be the position vectors of vertices capital A, B, C of tetra A, B, C respectively of tetrahedron OABC, full stop. So here small a bar is equal to, see the point A has coordinates A I cap plus 2 j cap plus 3 k cap. Small b bar is equal to, see point B is here 1, so 1 into I cap plus b into j cap plus 3 into k cap 3 k cap. So small b bar is I cap plus b into j cap plus 3 k cap. Also c bar is equal to, see point C is here 2 I cap plus j cap plus small c into k cap. So these are a bar, b bar, c bar. Let capital G with small g bar is the centroid of tetrahedron OABC. So centroid is given, that is 1, 2, minus 1. So small z bar is equal to I cap plus 2j cap minus k cap. Let 0 bar is the position vector of origin. So therefore by centroid formula, small z bar is equal to position vector of the first vertex O is origin, so its position vector is 0 bar, plus position vector of the point A, that is A bar, plus position vector of the point B, that is B bar, plus position vector of the point C, that is C bar, divided by 4. So that is Z bar is equal to A bar plus B bar plus C bar divided by 4, which is equal to. Now here 0 vector, if we add 0 vector to any vector, it doesn't matter. If we know that the algebra of vectors, or in some notes of vectors, A bar plus 0 vector is equal to A bar. So with this property, 0 vector plus vector A is vector A plus vector B plus vector C divided by 4. Now put the values of A bar, B bar and C bar. So what is A bar? A I cap, or we put here A I cap plus 2j cap plus 3k cap. This is vector A plus vector B I cap plus B into j cap plus 3k cap. C bar, that is 2I cap plus j cap plus C into k cap divided by 4. Again it is equal to. Now here on numerator we have 3 vectors. Take the addition of these 3 vectors, means see here A into I cap plus I cap, that is A plus 1 into I cap, plus 2I cap, that is A plus 1 plus 2 into I cap, that is A plus 3 into I cap, plus 2j cap plus j cap 3j cap plus B into j cap, that is 3 plus B into j cap, 3k cap plus 3k cap, that is 6k cap, 6k cap plus C, so it is plus 3 plus 3 6 plus C cap, so it is 6 plus C into k cap divided by 4. See, only we have taken the addition of 3 vectors on numerator. Addition of 3 vectors on numerator. So A bar, that is first vector A I cap plus 2j cap plus 3k cap. B bar, that is second vector I cap plus B into j cap plus 3k cap. And C bar is equal to 2I cap plus j cap plus C into k cap. So first A plus 1 plus 2, that is A plus 3 into I cap, 2 plus B plus 1, that is B plus 3 into j cap, plus 3 plus 3, that is 6 plus C, so C plus 6 into k cap divided by 4. Again it is equal to, now shift this 4 to left hand side, so it is 4 into g bar is equal to A plus 3 into I cap plus B plus 3 into j cap plus C plus 6 into k cap. Now but g bar is known here, see here, g bar is here I cap plus 2j cap minus k cap. So therefore 4 into I cap plus 2j cap minus k cap is equal to A plus 3 into I cap plus B plus 3 into j cap plus C plus 6 into k cap. Now that is 4I cap plus 8j cap minus 4k cap is equal to A plus 3 into I cap plus B plus 3 into k cap plus C plus 6 into k cap. So now by equality of vectors, these two vectors are equal. It means that their corresponding components are equal. By equality of vectors, we get 4 is equal to A plus 3, comma 2 is equal to B plus 3 and minus 4 is equal to C plus 6. So therefore it is A is equal to 7. After this, see here, shift this 3 to left hand side, we get 2 minus 3, that is minus 1. So minus 1 is equal to B, and here this 6 to left hand side, so minus 4 minus 6 become minus 10. So minus 10 is equal to C. So therefore A is equal to 7, B is equal to minus 1 and C is equal to minus 10. So these are the values of A, B, C. So therefore the point P is 7, minus 1, minus 10. Now in the half of the question, find the distance of P from origin. We have to find out the distance of the point P from origin. The distance of P 7 minus 4 minus 10 from origin 0, 0, 0 is length of OP is, I have written here, length of OP, and it is equal to square root of, we know that the distance formula for distance between any 2 points in the space. We have, if ax1 y1 and bx2 y2 be any 2 points in the space, then the distance between these 2 points is given by the formula square root of x2 minus x1 bracket square plus y2 minus y1 bracket square plus z2 minus z1 bracket square. See here 2 points are P 7 minus 4 minus 10 and second point is 0, 0, 0, that is origin O 0, 0, 0. So it is 7 minus 0 bracket square plus minus 4 minus 0 bracket square plus minus 10 minus 0 bracket square. So it is equal to square root of 7 square, that is 49, plus minus 4 square, that is 16, plus minus 10 square, that is 100. So it is equal to square root of 149 plus 6, 65 plus 165, square root of 165 units. So this is the distance of the point P from origin O. Today we will stop it here.